Those of you listening at home,
A figure of literally.
our dear Miss Hatley just saved my bacon. Thank you. I almost forgot to record this.
Shout out to Grace.
Yeah, I know.
Appreciate it.
All right, starting again. Number 1 for the chapter 6 test. It is an ellipse because x and y are both squared. They're both plus, but they have different coefficients, so it's not a circle. Number 2 is a hyperbola because x and y are both squared, but one is positive, one's negative, so it's a subtraction problem. Number 3 is a hyperbola, exact same reason. X and y are both squared, opposite signs. 4, if in case you're not sick of this already, is a hyperbola because both of them are squared and one's positive, one's negative. Once you get to number 5, you can no longer use the just stare at it and find out the shape trick. You must use b squared minus 4ac. I'll just say right now, I don't have the number, but I'll work it out in a minute. That is a hyperbola because the answer is greater than 0. Number 6, that you must use b squared minus 4ac, and you should get an answer of 0, which gives you a parabola. Remember, b squared minus 4ac is not the same as eccentricity. B squared minus 4ac is what we call escape strength. If it's less than 0, it's enclosed, circle or ellipse. If it's equal to 0, it's a parabola. If it's greater than 0, it's a hyperbola. Question?
I have these two. They're so nice.
Let me look. What? Where? Oh, hang on. No, you're right. I'll be tipped.
Yay, free
This
bills.
bizarre. Okay, let me double check and make sure it's the same version. This is 13u squared. Sorry, those of you listening at home. Yeah, it's the exact same. Wow. What was I smoking? Wow. Okay, so I can say that about me. Thank you very much. So yes. For those of you listening at home, I'm calculating the score on my watch. I'm trying to calculate it. No. I actually not say square.
So the graphing calculator?
No, I wish. Actually, John, do me a favor. After class, if you could bring that up so I can change the grade book, that'd be awesome. So number 5, hyperbola. And number 6, parabola, because you got an answer of 0. Any repeats so far? All right, number 7, graph and analyze. What a mess. The center, number 7 is a circle. You need double complete the square. The center is 3, 1. The radius is radical 7. Number 8, is everybody got number 7? Number 8 is an ellipse. The center is -4, -1. The horizontal radius is 3. The vertical radius is 5. I need a nap. So the horizontal radius is 3, vertical radius is 5. A, which is the major radius, is 5. B, the minor radius, is 3. The focal move is radical a squared minus b squared, which should be radical 16, better known as 4. So the focal move is 4. So there are 2 foci. It's technically -4, -1 plus 4, -4, -1 minus 4. I'd just like you to simplify those. It's -4, 3, and -4, -5. There are 2 major vertices. They are -4, 4, -4, -6. Head up, please. And the 2 minor vertices, which they call covertices, are -1, -1, and -7, -1. And that should do. And it repeats on number 8. Number 9 is a hyperbola. I would put the x minus 1 parentheses squared, I would put that over 1. So the center on this thing is 1 comma negative 2. Horizontal radius is 1. The vertical radius is 3. A is the leader radius, which is 3. B is the follower radius, which is 1. The focal move is radical A squared plus B squared, which should give you radical 10. This thing is opening up and down because Y is the leader. So when you draw your guide box, start at the center, 1 comma negative 2. You go 1 left, 1 right, 3 up, 3 down. Draw your box. Draw your diagonal asymptotes from corner to corner, which should go through the center. And then the top and bottom of the box are where you start your hyperbola. You go down from the bottom and up from the top. The vertices that you draw from are 1 comma 1 and 1 comma negative 5. The foci are 1 comma negative 2 plus radical 10 and 1 comma negative 2 minus radical 10 because they go up and down. Asymptote slopes, the first slope is 3. The second slope is negative 3. Whoops, I dropped my marker. So the equations for those asymptotes are y minus negative 2 equals 3 parentheses x minus 1. You could do y plus 2 if you want. And the other asymptote equation is y minus negative 2 equals negative 3 parentheses x minus 1. And I think that's it. Any repeats on number 9? All right, number 10, you needed to do complete the square. It is a sideways parabola opening to the left. The vertex is 0 comma negative 3. The height multiplier is negative 1. The focal move is negative 1/4. So you move 1/4 space to the left, so the focus is negative 1/4 comma negative 3. The directrix moves to the right 1/4, and it's a vertical line, so it's x equals 1/4. You have to do x equals, not just 1/4. And the axis of symmetry is y equals negative 3. Any repeats on number 10? All right, number 11. In proper form, this thing is an ellipse. It should be x minus 4 parentheses squared over 9 plus y minus 2 parentheses squared over 225 equals 1. Can we need that repeated? You could also have the clumps reversed. You could have y minus 2 parentheses squared over 225 plus x minus 4 parentheses squared over 9 equals 1. That would be fine. If it's addition, you can flip it around. That was number 11. Number 12, there are 2 intersection points, 2 comma 2 and 6 comma 6. Number 13, that is a parabola, eccentricity of 1. Number 14, that is a hyperbola, so you need to do c over a. The eccentricity is 2 radical 3 over 3. If you had 2 over radical 3, that's right, but you have to get the radical out of the basement. And it repeats up to number 14. And number 15, that is an ellipse, so the eccentricity is radical 11 over 6. You have to do double complete the square on that in order to find C and A. And number 16 is a circle, so it must have an eccentricity of 0. 17. It says graph each function, then name the asymptote equations and the center. Number 17, the center of the graph is negative 2 comma 0. I would put a little x there. And then put a vertical asymptote right through it, horizontal asymptote right through it. The equations are horizontal asymptote of y equals 0, vertical asymptote of x equals negative 2. When you start at the center, the graphing pattern on this is 1 to the right, 3 down, 3 to the right, 1 down. Then in the other branch, you can go left 3, up 1, and left 1, up 3, and branch them. So there should be a branch in the upper left and the branch in the lower right, because you notice the negative in front. It is negative. I would put the negative on top. It makes it easier to see. Does that make sense? Number 17, everybody follow that? Any repeats? Okay. Number 18, and I can work one of these on the board if you want. Number 18 starts at a center of 0, negative 2. So the vertical asymptote is x equals 0. Horizontal asymptote is y equals negative 2. The pattern for graphing is from the center, 1 to the right, 4 up, 4 to the right, 1 up. And in the other way, left 4, down 1, left 1, down 4. You could also do right 2, up 2, and left 2, down 2. Those are kind of optional. And then you should have a branch going upper right and a branch going lower left. That'd be okay. Number 19, extra credit. There is one intersection, 1, 3. Number 20, what is the eccentricity of that diagonal hyperbola? Radical 2. Number 21, give your own example of a circle and a parabola that intersect 4 times. Kind of like the problem we did in the board. You can choose whatever circle you want, whatever parabola you want. I would center the circle at 0, 0, makes it much easier. And then make sure the parabola, like if you're doing an upward parabola, which is easier, make sure the bottom is below the circle and make sure it's totally skinny. Be careful. If you make a height multiplier of bigger than 1, that makes it skinny. If you make a height multiplier of really small, like 1 over 100, that actually makes it really wide, and it'll miss the circle altogether. So be careful on that. A height multiplier of 100 would be fine. A height multiplier of 1 over 100 would probably miss the circle. Does that make sense? That is it. So at this point, I am open to questions. Any of those you want to see dissected? Because those are going to boomerang back on the semester exam. Yeah. Yeah, definitely. Number 10, fast forward, or fast rewind, I should say. Yes. Number 10 is this. X equals negative y squared minus 6y minus 9. Again, it's weird because the x and y's are flipped around, but you do the same sort of complete the square that you do normally. This is a parabola because one variable is squared, one's not. Question, who's the leader? Actually, John, go ahead. Is it x or y? Ah, you'll need to know this. In a parabola, the squared term, the non-squared variable is the leader, and it belongs in front. So in this case, x is right where it belongs. If I had messed up those letters, you would have looked around and said, oh, x is the only one that's not squared. That's the leader, it belongs in front. So let's try it. In order to complete the square, first step, set it equal to 0. So that's step 1. Step 2, cancel the c and leave a blank. So I'm going to add 9. So negative y squared minus 6y plus blank equals 9. So step 1 is get it equal to 0. Step 2 is cancel the c. And what I mean by cancel the c, normally it's like y equals ax squared plus bx plus c. So I'm canceling the c, the last number. Now, you can also have the backwards version. X equals ay squared plus by plus c, which is this case. But we're canceling the c no matter what. Step 3, undistribute the a, which in this case is negative 1. So you're going to divide negative 1 out in front and leave behind y squared plus 6y plus blank, and it still equals 9. So step 3 is undistribute the a. Step 4, compress it into a binomial squared. So what binomial squared did this come from? Actually, John, step me through this. Y squared plus 6y plus blank. It's square the first, double product, square last. Where did it come from? Exactly. And this is squared. What number should be here? 9. Good. How much extra weight should I put over here? Very good. I was going to put 9, but it's negative 1 times bigger than we thought it was. So this is going to be negative 9. And that adds up to what? 0. And now, Step 5 is get it back equal to 0, so congratulations, it's already done. -1 parentheses y plus 3 parentheses squared, minus 0 basically, equals 0. This, you can put the x back in front now. -1, just remember, when you have vertex form, this is from like last chapter before, a parentheses x minus h parentheses squared plus k. The other version looks a lot like it. A parentheses y minus k parentheses squared plus h. In either case, the parentheses has to have a minus in it, so you gotta fix it. So it's y minus -3 squared. And this has to be plus, well, it's still 0, but whatever. So the vertex on this thing is, remember, if x and y are backwards, then these two numbers are backwards. It's 0, comma, -3. So there's your vertex. To graph this thing, it's going sideways, because x is the leader, so it's gonna go left, right. The pattern is normally over 1, up 1, over 2, up 4, over 3, up 9. Let's go down to the vertex and see what happens. You have 0, comma, -3. And it's gonna, remember, you have to tilt our head sideways in order to see this. This is, to the right is the new up, and to the left is the new down. And this thing's going down. It's a normal height multiplier, so it's over 1, down 1, over 2, down 4. Let's try it. So over 1, down 1, both ways. And then over 2, down 4, both ways. And here's your brown. Okay? Now, that'll handle the graph, and it'll give you like at least 3 out of 10 points if you get the graph. You've got the vertex, which I'll just recopy it up here. 0, comma, -3. That's here. Remember, this thing's opening to the left, so the focus must be going to the left. The height multiplier is -1. The focal move for a parabola is 1 over 4a. So that's 1 over 4 times -1, which is -1/4. That's the focal move, which means that's how far the focus moves. And it moves 1/4 of a space backward. It's going to be right here. It's 1/4 of a space to the left. So the focus is, instead of 0, comma, -3, it's -1/4, comma, -3. Does that make sense? So you go to the left 1/4 space, and the directrix, which is the line underneath the parabola, is in the opposite direction. It goes 1/4 space to the right. This is a vertical line, which means it's x equals something. In this case, it's x equals positive 1/4. That's the directrix. And last but not least, axis of symmetry is the line that splits the parabola down the middle, and that's y equals 3. Okay. And there's your problem. Okay. Question? Yeah, it is. See, that's fast. Okay. Does that make sense? Good. Next. Now's a good time to ask. No question is too humble. Yeah.
Can you do 11?
11. I'm 11. Oh yeah, that beast. Yeah. This is the one where you reconstruct the formula from scratch. And by the way, I'm going to be posting this on YouTube, so if you don't get the notes yet. Is anybody still writing this? Okay. Check on YouTube. So the first thing, they didn't even tell you what shape it is. They gave you 2 vertices. We've got 4, comma, 17 and 4, comma, -13. They also gave you 2 foci. 4, comma, 2 plus 6 radical 6 and 4, comma, 2 minus 6 radical 6. Now, if you're feeling sneaky and clever, the foci may actually tell you 2 things: what the focal move is and where the center is. So let's pretend you don't see that. My first move would be to graph this as best I can. 4, comma, 17, I'm just going to fake these numbers. 4, comma, 17 is like right here. 4 comma negative 13 is like down here. That immediately tells you something. The thing is oriented up and down. I have no idea what kind of shape this is, but I do know there are 2 shapes that it cannot possibly be. Name one. Actually, hey, name me one shape that this couldn't possibly be. Why not a problem? You're correct. I'm sorry? There's only one vertex in a parabola, and this has 2, so it can't possibly be a parabola. Somebody else, tell me one other shape it cannot possibly be. Yeah. Look.
Wait, what did they say?
What kind of shape could it not? She said parabola. Circle. It can't be a circle because it doesn't have foci, it doesn't have vertices at all. It must be either an ellipse or it must be a hyperbola. What am I saying? Or hyperbola. And I don't know yet. Now here's where you need to either do a little mental math or grab a calculator. Because what is 6 radical 6? I don't know. 6 radical 6. By the way, this is really radical 36 times radical 6. So I think this is radical 216, sorry. So if you want to do it in your head, here's how to do it. Figure out what this is, and then say, how much is that? Well, radical 216 is a horrible decimal, but the closest one is radical 196, and the bigger one is radical 225. 196 is 14? No, yeah. And 225 is 15. So whatever this thing is, it's 14 point something. By the way, if you want to spare yourself all this agony, just do 6 times radical 6 on a calculator and see what it is. It's 14 point something. Now, can somebody tell me where the center of this thing is? There's a way to tell just by staring at it, and there's a way to tell by math. Paul, help me out. How do you find the center of this thing?
Well, it would be 4, 2,
How do you get that so fast?
because the focal move is 6 radical 6, so you can just know that it's 2.
Yeah, the focal move goes up and down from the center, so the center must be 4 comma 2. That means that we have a vertical radius of 15. This is 14 point something. 14 point, I have no idea. But it's between 14 and 15. That means it's less than 15. It's like here, here. Tell me, math people. If the foci are inside, what kind of shape are we talking about here? It's got to be an ellipse. Because remember, the shape follows the foci. An ellipse is where the foci are inside, because it pulls the shape toward each other. Hyperbola is when the foci are outside. That's the way to tell. So this has to be an ellipse. I'm immediately going, so it's not hyperbola, it is an ellipse. I would immediately write this. First of all, it makes me feel better. X minus something squared over something plus y minus something squared over something equals 1. It's a feeling of satisfaction. You just slap that down and it feels like you're half done. You're about 1/5 of the way done. We also know the center. You can either average these 2 vertices and you will get 4 comma 2. You can average these and get 4 comma 2. Or you can just look at the focal move and say they must have been moving from 4 comma 2. Which means you put a 4 here and a 2 here, and you're actually about halfway done. And, better yet, the vertical radius is 15. That belongs here. 15 squared. All we need to do is find the horizontal radius. The good news and bad news. The good news is that's the only thing we have left to find. The bad news is they didn't give us anything about left, right. No points, no nothing. But there is a focal move formula. If you know it's an ellipse, then we know the focal move is radical a squared minus b squared. That's the only clue we have. And we happen to know how much the focal move is. 6 radical 6 equals, problem is what's A and what's B? Well, I have the vertical radius, but the question, is this A or is this B? In an ellipse, A is the major radius, but I don't have the other radius. How am I supposed to know which one is major? I have one of them. Is this the major radius or is it a minor radius? If the foci are going that way, this must be a major radius, because the foci follow it. Right, it follows the foci really. So we now know that A is 15. 15 squared plus, whoops, minus. I don't know squared. That's okay, let me simplify that. So this is actually radical 216. Equals radical 225 minus b squared. I just expanded that out so it's easy. We're about to square both sides. I want to get b by itself. So the furthest thing away is the radical, so you square it to get rid of the radical. This becomes just regular 216, the square and square root cancel. Equals, square and square root cancel, 225 minus b squared. Now it's an algebra problem. Subtract 225 from both sides. It should be negative 9 equals negative b squared. Divide by negative 1, so b squared equals 9, and b is equal to 3, which by the way is our missing radius. Put that here, and you're done. Does that make sense? It took a little effort. You had to find a bunch of missing pieces, but be patient and be thorough, and it shouldn't be too hard. Next. Any others? Now is a very good time to ask. I'm on the clock, so.
You do
12, let me look. Yeah, system of equations. Start over here. We've got x squared plus 5y squared minus 51x plus 3y plus 72 equals 0. And then we have another one that was negative x plus y equals 0. What shape is the top one? Yeah.
ellipse.
That's an ellipse. They're both squared, both positive, but different numbers in front. That's an ellipse. And Paul, what's the bottom thing? It's line, yeah. Now it's a weird form. I would add x to both sides. It's y equals x, which is actually a pretty boring line. It's a slope of 1, a y-intercept of 0. That's interesting. You don't have to graph this unless you want to. What I'm going to do, every time I see a y, I'm going to plug an x in. So it looks like this. X squared plus 5x squared minus 51x plus 3 times x plus 72 equals 0. You're going to have to simplify this a little bit. This is going to be 6x squared, these combined. Negative 51 plus 3 is negative 48x plus 72 equals 0. And now you have to choose your favorite method to solve it. You could do the quadratic formula. It's actually kind of big and ugly. I would do factoring on this because you can pull a 6 out. X squared minus 8x plus 12 equals 0. And that factors by unfoil to x minus 6, x minus 2. Does that make sense? Two numbers that add up to negative 8 and multiply to be positive 12. Solve by zero product property, set these equal to 0. I mean, you can set this equal to 0 too, but it's a dud. X equals 6, x equals 2, which is great. Don't stop there. I need to find the y's. Good news is the y is going to be identical to the x. So the 2 points are 6, 6, and 2, 2. Does that make sense? Next. Questions? Yeah, go.
Can you do 14?
14, so that's the
Right.
eccentricity. Got it. Is everybody okay with this so far? Don't let me pass you by. I would love a new whiteboard for Christmas.
Yeah.
So we've got y minus 4 parentheses squared over 120 minus x plus 1 parentheses squared over 40 equals 1. Now all they want is the eccentricity. Eccentricity of a circle is 0 and a parabola is 1. You don't need formulas for that. Everything else is c over a. This is a hyperbola because it's a square minus a square. So we now know the horizontal radius is radical 120. Remember, this is already squared. And the vertical radius is radical 40. You can simplify those in a second, but which one is A? Actually, hey, in a hyperbola, which one is A? How come? Oh, wait, I've got these backwards. Sorry, that's stupid. All the y stuff is vertical. So I'm sorry, go ahead. The vertical, why do you say that? It's the leader, correct. It doesn't matter who's biggest. This is the leader because it's first. And it's a positive one. So this is A. And C in a hyperbola is radical A squared plus B squared. So it's going to be this. C is equal to radical 120 squared plus radical 40 squared. This actually comes out nicely. This becomes just plain old 120, and this becomes 40. So it becomes radical 160. So that's the focal move. Now you do have to reduce it. That's going to be, there's a 16 in there, times 10. So we're looking at 4 radical 10, the focal move. And then A is radical 120, which boils down to, what goes into that? I know there's a 4 in there. And then radical 30. I guess that's it. It's 2 radical 30. So look at this. Eccentricity is 4 radical 10 over 2 radical 30. There are a lot of people who multiply top and bottom by radical 30. That's legit. Question, oh math people. Oh, Peter. What's a radical times a radical? Not necessarily. What's radical 2 times a radical 3? Mm-hmm. A radical times a radical is a radical. Good. What's a radical divided by a radical? Anybody? Radical. So what's radical 10 over radical 30? Does that reduce? Yeah, it's radical 10 over 30. Which means radical 1/3, which is radical 1 over radical 3. In other words, you can just reduce these. It becomes radical 1 over radical 3. A radical over a radical is legal. So I'm going to reduce these and reduce these. 4 over 2 go to 2 over 1, and then radical 1 over radical 3. This is just 1, so it becomes 2 over radical 3, and now get the radical out of the basement by multiplying top and bottom. And you get 2 radical 3 over 3. There's your comments. Right? So it's a little bit annoying for the simplification at the end, but there we go. Everybody okay so far? Any others you want to see? Now's a good time. Do not be bashful. Bashfulness never passed a test. Go.
Can you do 15?
15, yeah. I'm gonna turbo this a little bit because it's gonna be a complete the square problem. The good news is it's not quite as bad as the other one as far as simplifying goes. Bad news is you gotta complete the square. 36x squared. This is number 15. 36x squared plus 25y squared plus 576x minus 300y minus 396 is equal to 0. I will tell you right now, factoring is your best friend on this problem. Group the x's. 36x squared plus 576x plus blank. We're going to double complete the square on this. And then 25y squared minus 300y plus blank equals, and I'm going to add the 396 to the other side. So we don't trip over it. You okay? Yeah. Yeah, go for it. Here I'm going to pull out a 36. X squared plus 16. X plus blank. Feel free to use a calculator on that. There's no shame in that. And then 25 parentheses y squared minus 12y plus blank equals 396. Is that right? 16? 6 times 6 is 36. Yeah. Okay. This collapses to 36 parentheses x plus 8 squared. So there should be a 64 here. Square the first, double the product, square the last. Now how much extra weight? A lot. I don't even know what that is. It's 64 times 36. 6 times 4 is 24, carry the 2. 36, carry the 2 is 38. 3 times 4 is 12, carry the 1. 6 times 3 is 18, with the 1 is 19. So 4, 0, 13, 2304. So this becomes plus 2304. And this side, this is 25 parentheses y minus 6 squared. So this should be 36. 36 times 25, 900, I think. So this all adds up to 23, 26, this is 27, this is 3600. So there is so far. This answer has to get down to 1. I don't want these 36 and 25 here. Divide everything by 3600. This is an ellipse, so it's got to have an answer of 1 when we're done. 3600, 3600, and then reduce these. 36 goes into 3600 100 times. So x plus 8 parentheses squared over 100 plus 25 goes into 36. Hang on a second. 900? I think. Yeah. So y minus 6 parentheses squared over, is that?
It's 144.
144, thank you. Wow. Brain is going off on the vacation line. So the horizontal radius is 10, the vertical radius is 12, and the vertical radius is A. And the focal move is A squared minus B squared, so this will be B. So it's going to be radical 144 minus 100, so it's going to be radical 44. And you can split a 4 off there, times 11. So it's going to be 2 radical 11. So C over A, which is the eccentricity, is going to be 2 radical 11 over 12, which boils down to radical 11 over 6. Does that make sense? Thank you for saving my bacon on that one. Anything else you want to see? Friendly reminder, I am planning on tomorrow being an in-class retake. So if you don't want to take a retake, bring something quiet to work on for the hour. If you do want to retake, then by all means do. Any other questions you want to go through? speak now or forever hold your peace. Is everybody feeling okay in graphing the diagonal hyperbolas? It's over 1, up 1, over 2, up a half, over 3, up a third, etc. Feeling okay? Nobody else? No other questions? Otherwise, I'll assume you can knock everything out of the park. Alrighty, got about 7 minutes. Congratulations. You just let your brains cool off. We do not, I don't want to have a new topic when the poor souls downstairs are suffering in purgatory or taking the test. So, go ahead and just kick back for about 7 minutes, relax. For those of you listening at home, click like and subscribe. I'm sorry, yeah, go ahead.
I just have a question about, I got this one wrong.
Oh, I'll take a look, just a second. Cheerio, y'all. Talk to you later, bye.